In this video, we will see how a team can use Paralus Access Manager to control and manage remote access to their dev, staging, and production clusters to developers and operation personnel. We will start by creating 3 projects called dev, staging, and prod. We will import our Kubernetes clusters into each of these projects. From an access control perspective, here is the access model that the organization wishes to implement. In any organization, there can be tens or hundreds of users. It becomes impractical to try and manage access control rules on a per user basis. It is therefore highly recommended to use groups as a logical construct instead. Admins can map groups to access rules and then can add or remove users to the groups at any time. In our case, let us start with something simple and we'll create 2 groups with the following access rules. Now let us add users to our 2 groups as per the example below. Their ops-john at rafe.co as a user is added to the operations group, and developer-sally at rafe.co is added to the developers group. Now that we have our access rules configured, we are ready to import our clusters into the respective projects. Admins can do this using the Paralus console or the Paralus CLI. Let us look at what this process looks like using the Paralus console. Provide the name for the cluster, and Paralus will provide you with a bootstrap YAML. Once the admin deploys this bootstrap YAML to their Kubernetes cluster, it automatically downloads the necessary software components and deploys the Paralus agent to the Paralus system namespace. It then registers the cluster with the Paralus Access Manager server. This entire process just takes a few seconds to complete. In our demo, we have successfully imported our clusters into dev, staging, and prod projects. Now let us log in into Paralus and try accessing our clusters. Let us first log in as the operations user, ops.john at rafe.co. Notice that user has access to all 3 projects, dev, staging, and prod. Let us navigate to the prod project and click on kubectl on the Paralus console. This opens a zero trust web shell that the user can use to type in required kubectl commands. The service account for this user is injected into the remote cluster just in time. Let us look at the service account using kubectl and notice that the service account for this user was created just a few seconds ago. This service account is also ephemeral and will be automatically deprovisioned from this cluster after the user's session expires. Let us describe the service account to view it. Now let us look at the RBAC that is automatically configured on this cluster for the user. As you can see here, this user as an administrator has cluster-wide privileges. Now let us log in as the developer-sally at rafe.co. Notice that this user only has access to 2 projects, dev and staging. As per our organization's access rules, developers do not have access to the production environment. This developer prefers to use the kubectl CLI and not the web console. So let us have Sally download the consolidated kubeconfig file from Paralus to the laptop. Let us switch context to the dev cluster. On the dev cluster, Sally has both read and write privileges to the Apple namespace. Let us list the pods in this namespace. Note that even though the Kubernetes cluster is behind a firewall, Sally is able to perform kubectl commands against it. Now let us try deploying a pod into the Apple namespace. In a few seconds, you should see the pod operational. So Sally was able to perform both read and write operations in the assigned Apple namespace. Now let us try listing all namespaces on the cluster by typing in kubectl get namespace. As expected, this command is rejected because the developer, Sally, does not have required privileges to do anything outside the Apple namespace. In the first few steps, we configured access rules for users that helped us control who can do what. It is a very standard security practice to also periodically answer the question, who did what when, and who is doing what. So in addition to acting as a central access point for all clusters in an organization, Paralus Access Manager also audits all actions performed against Kubernetes clusters under management. Let us now look at the centralized audit logs for kubectl. Let us navigate to the audit logs. Notice that you can see the exact kubectl operations performed by the operations user a few minutes back. In summary, organizations can use Paralus to, number one, securely access cloaked Kubernetes clusters running behind corporate firewalls using both web-based kubectl and the kubectl CLI. Number two, Paralus to automatically create just-in-time and ephemeral service accounts with automatic federation of RBAC. Number three, they can use Paralus to maintain a centralized audit trail of all kubectl activity performed by users of Paralus. Well, thank you for watching.